Hey, I'm Mitchell. Welcome to another video in the RSP education series. Imagine you're out in the field. A pump isn't performing right and the control room's getting incorrect readings. You're staring at a screen wondering, is it the sensor or the wiring or the signal itself? This is where understanding how signals work, 4 to 20 milliamp, 0 to 10 volt, Fieldbus in HART, for example, it makes all the difference. These aren't just technical terms. They're the language that your instruments use to talk to your PLCs, your distributed control system, and ultimately to you. In this video, we're going to break down the most common analog and digital signal types, where they're used, their strengths and weaknesses, and how they tie into real-world systems like smart valve positioners, safety instrumented systems, and industry-specific setups. Let's decode the signals behind your instrumentation so that the next time there's a problem, you'll know exactly where to look. If you like this kind of content and want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get right into it. So 4 to 20 milliamp analog signals. This is the most common signal type used in process control. 4 milliamps is called a live zero. This means if the wire breaks, you'll notice right away. 20 milliamps represents the full signal range, like maximum flow or pressure. The big advantage is it's very resistant to electrical noise and it works well over long distances. Then you got 0 to 10 volt analog still. This signal is simpler, but it's not great for long distances. Voltage drops as it travels, which can affect accuracy. You'll see this used a lot in HVAC systems and building automation. Fieldbus, now we're going digital. Some examples are going to be foundation Fieldbus and Profibus PA. Fieldbus can send many signals on just one cable. This is going to reduce wiring. It also allows two-way communication so you can get diagnostics and make configurations remotely. HART protocol, that's a hybrid. It's analog and digital. It uses a standard 4 to 20 milliamp signal for real-time control, but adds a digital signal on top. There's two ways it's used. For supervisory control, so this is the most common, 4 to 20 milliamp does the control, while HART is used for setup and diagnostics. For primary control, it's a little bit more rare. Technically, HART can control devices directly, but most systems use it just for monitoring. Foundation Fieldbus, or FF. It's a digital two-wire system that's safe for hazardous areas. It supports something called function blocks. That means your control logic can run inside the field devices themselves, not just in the PLC. Profibus PA. This works a lot like Foundation Fieldbus, but it connects into Profibus DP networks. You'll see Profibus PA more often in European industrial plants. This is the US. Now let's talk pneumatic versus electric actuators. Pneumatic actuators, these run on compressed air. They're fast, they're strong and simple, but you do need an air supply. They're very common in oil and gas applications. Electric actuators, these run on electric motors. They're more precise, they're easier to program, and you don't need an air system. You'll often see these in water treatment and HVAC systems. Then you also have smart valve positioners. They automatically adjust how far a valve opens or closes to hit a precise set point. They also self-calibrate and give you useful diagnostics, like letting you know if the valve is sticking or wearing out. Some examples, Fisher makes a DVC, a digital valve controller. It's a popular choice in oil and gas. Siemens makes SIPART PS2. It's widely used in chemical plants. So now let's get more specific about industry-specific instrumentation. Oil and gas, you're going to see a lot of custody transfer flow meters. These meters, they need to be extremely accurate because they're used for financial transactions. So every drop counts. Types include Coriolis, ultrasonic, and turbine meters. They often require API or ASTM certification. In pharma, you're going to see sanitary sensors. In pharmaceutical plants, sensors need to stay clean and safe. They're designed with no crevices where bacteria could grow. They're easy to clean using CIP or clean-in-place systems. And 3A compliance ensures they meet strict food and drug safety rules. Power plants, you're going to have a lot of vibration monitoring. So turbines, pumps, and compressors all need vibration sensors. These detect problems like imbalance, misalignment, or bearing wear. This helps you catch failures before they become disasters. All right, so let's recap. 4 to 20 milliamp is the backbone of process control because it's reliable, noise resistant, and great for long distances. 0 to 10 volt is simple and common in HVAC and building automation, but not ideal for longer runs since the voltage drops. Fieldbus protocols like Foundation Fieldbus and Profibus PA, these reduce wiring and allow two-way communication. HART gives you the best of both worlds, analog control with digital diagnostics layered on top. We also touched on how these signals come into play with actuators, smart valve positioners, and safety systems in different industries, from oil and gas to pharma. Understanding these signal types isn't just theory, it's practical knowledge that helps you design better systems, solve problems faster, and make smarter decisions in the field. For hundreds of thousands of industrial automation products, go to our website. That's rspsupply.com, the internet's top source for industrial hardware.